Good morning. How's everyone doing today? So we just heard Mike talk about some of the awesome new stuff that's going on in React Native, some of the new features and tooling that's been shipping in the last year or so. Some of this stuff is available for all of you to use today, like Hermes, and some of it's coming really soon, like in version 61, like fast refresh. So with all of these improvements, I'm really excited about where React Native is today. I feel like it's never been a better time to be a React Native developer. And one of the really cool things about this community is how many people are involved in making React Native better. So thanks to all of you for your contributions and making React Native awesome. So what I want to talk about today is actually some stuff that's a little bit further in the future. So the way that we're thinking about this is, this shouldn't have any effect on how you use React Native today, or your decisions to use React Native today. But we hope that you're interested in the direction that we're headed and are excited about what's coming up next for React Native. So I'm Emily Janzer. I am a member of the React Native core team at Facebook. And one of our responsibilities on the core team is to think about the longer-term direction of React Native and some of the longer-term projects that we need to take on in order to get to where we want to go. Like, what should React Native look like in a few years? What kinds of capabilities do we want to support? And how do we get to there from where we are today? One example of these kinds of long-term projects is Hermes. Hermes was a project that took a team of people working on it for a matter of years. I mean, writing a JS engine is no joke. We think that Hermes is awesome because of some of the performance benefits that we're getting from it today. But we're also really excited about some of the future optimizations that this is going to enable for us. So Hermes is a long-term project that's already shipped. Today I'm going to be talking about some stuff that's still in progress. Right now we're in the middle of a project to re-architect React Native piece by piece. Some of these pieces are currently being tested at Facebook, and we're now in a place where we're thinking about how we get them into your hands. I'm also going to be talking a little bit today about a new addition to this new architecture project, which is still in the very early and experimental stages. And this is a project to rewrite React Native's initialization path to no longer use a piece of infrastructure called the Bridge. And then finally, we'll talk about what all this means for you and your app or your library. But first, I'll briefly introduce myself, although Mike already kind of beat me to it. I've been working on React Native apps as a product developer for about 5 years now. I started out working on the Facebook Ads Manager app, which is the first fully React Native app for iOS and Android. From there, I went to Oculus, where I helped build the companion app for Oculus Quest and Oculus Go. And then last year, I joined the React Native core team at Facebook, where I've been working on some startup performance stuff and now this new architecture project. So we've been working on this project for a little while, and we've actually talked about it publicly before. Those of you who were at React Native EU last year might remember my colleague David talking about a rewrite of React Native's UI layer to enable native interop and improved performance. Then a few months later at ReactConf, Ram gave a talk about this same rewrite, as well as a rewrite of our native modules system. So you might be wondering, what's going on with this project? We've been talking about it for a while. Are we going to ever get it, or are we just going to keep talking about it forever? The good news is it's coming soon. Facebook's philosophy when it comes to open source software is that we're not going to ask you to run anything in production that we're not running in production ourselves. So we've been working on testing the new architecture in production at Facebook to stabilize it and battle test it. Right now, we're working on rolling out the new architecture at Facebook so we can discover all of the bugs and edge cases and rough edges before we make it available to all of you. Once we feel confident that the new architecture is stable and ready for prime time, that's when we'll roll it out to the open source community. With all that in mind, we do think we're ready to start rolling out the new pieces, we do think we're getting close to being ready to being able to roll out some of the first pieces of this new architecture. And we're planning on doing that at the beginning of the new year. So when I talk about new pieces of this, what do I mean? The new architecture is going to be coming to you in 3 phases. The first phase is a faster, type-safe native modules system. The second phase is the new renderer that enables native interop. And the third phase, which I'm introducing today, is a new, faster initialization path for React Native that removes the stuff we no longer need with the first two phases of this project. So we've talked about the first two phases before, so I'm only going to briefly summarize them now. But if you want to know more, I recommend checking out David and Ram's talks from last year, not from here. So the first phase is the new native modules system. You might have heard this referred to as turbo modules. This is offering improved type safety between JavaScript and native code. It's also faster because there's less overhead associated with calling native methods from JavaScript. And we're initializing native modules lazily by default, which improves startup performance. This is actually an optimization that we've had at Facebook for a while now, and we found that it's a pretty significant TTI win. With the new native modules system, we're making this the default behavior. The new native modules system is currently in testing at Facebook, and we're working on rolling this out to all of Facebook right now. So this will be coming to you in the beginning of 2020. All the code for this is on GitHub, but it's just not yet ready for you to use. Next, we have the new renderer, and this is what you've probably heard us talk about as Fabric. This is a C++ rewrite of React Native's UI layer. The new renderer is thread safe, so it no longer requires layout and measure to be done in a dedicated thread. And it also enables synchronous layout and measure APIs. This makes it much easier to integrate React Native with native frameworks. And it also means that we can fix some of the UX issues and bugs with components that heavily rely on measure APIs like text input and scroll view. In addition, we're also bringing some of the same optimizations that we're getting for the new native module system to our view managers. We're introducing type safety between native code and JavaScript for our view managers, and we're lazily initializing them. So this means faster startup and fewer bugs. This is also currently testing at Facebook, and this year we're focusing on migrating the Facebook app to using the new renderer. Again, the code is also on GitHub for this, but not quite yet ready for all of you to use it. And this will be coming to you a little bit later in 2020. So the final phase of this project is a new initialization path that doesn't rely on the bridge. In order to understand what this is and why we're doing it, we should probably talk about what the bridge is and how React Native works today. So let's say you're writing an app using React Native. You've got your JavaScript code and your native code, whether that's Java or Objective-C or maybe C++, depending on what platform you're targeting. On the JavaScript side, you're writing React components. And then these are backed on the native side by view managers, which are responsible for creating the appropriate native view for that React component. We also have native modules, which are exposing some specific, like platform-specific APIs to JS. And these are backed by native implementations as well. All of these pieces communicate with each other using something called the bridge. And you can think of the bridge as basically a message bus between your native code and your JavaScript. All communication through the bridge is asynchronous, batched, and serialized. So objects are serialized as JSON as they're sent across the bridge. This means if you're calling a method on a native module, and you want to get the return value from that method, you have to pass in a callback to be able to use it, even if that native method is synchronous. And if you want to access an object from JavaScript in native code, that's going to have to be serialized as JSON as it's sent across the bridge. This approach has worked pretty well for us so far. The fact that all JavaScript is being executed on a dedicated background thread and you can only call into it asynchronously means that we don't have to worry about blocking the main thread, which is pretty nice, and we don't have to worry about thread safety issues. But it does have some downsides. There's an overhead associated with using the bridge, especially if you're sending a lot of large objects. React Native's new architecture is no longer relying on the bridge for communication between native code and JavaScript. Instead, we're using an API called JavaScript Interface, or JSI. JSI is how we interact with the JavaScript engine from C++. It's an engine-independent API, which means that it works for JSC and for Hermes. And we use JSI to create the JavaScript runtime, load the JS bundle, and then most importantly, calling functions between C++ and JavaScript. JSI also makes it possible for us to access and manipulate the JavaScript heap from C++. which means that we can create and access JS objects from native code. By using JSI directly instead of relying on the bridge, we can reduce the overhead for communication between native code and JavaScript. So with our new architecture, we're using JSI directly instead of the bridge in a lot of places. With our new native modules system, we use JSI to call native methods. And with our new renderer, we're using JSI to create and update views. But we still have the bridge, even though these things aren't using it anymore. And we're still paying the cost to initialize it. And that brings us into the new initialization path. Let's take a look at what React Native Startup looks like today. You have your native startup, where we're loading classes and just getting everything ready for JavaScript. You have your JavaScript initialization, where we load the JS bundle. And then in your product code, you're probably fetching some data from a server somewhere, so you have that time. And then we're rendering your React components and actually drawing stuff on the screen in the native render phase. Let's take a closer look at the native startup part. What we're doing here is we're loading classes and C++ libraries. We're initializing all of the native modules that are used by your application. We're initializing all of the view managers that are used by your app. And then we're setting up the bridge. With the new architecture, we're no longer eagerly initializing our native modules and view managers. Instead, those will be initialized lazily, which is a startup performance improvement. At Facebook, we found that when we enabled lazy initialization for our native modules, we saw around a 400 millisecond improvement. So this is going to be pretty significant. But you'll notice we are still initializing the bridge. And included in this is a bunch of classes and initialization work that we don't really need to do anymore. Like, we're still initializing the old the UI Manager module, but Fabric doesn't use that. So that's some of what we're changing in the third phase of this project. We're getting rid of the bridge. So instead of setting up the bridge, we're just going to only keep the pieces that we need, like creating and configuring the JavaScript runtime. And this should improve native startup a little bit. But that's not the only place that we can improve performance with a new initialization path. Let's look at the next step in startup. So this is where we're loading the JS bundle. And that includes a bunch of stuff that we need to do in JavaScript to make sure that the JavaScript environment is ready for you to use. Most of this stuff is happening in a file called initialize core. A lot of what we do in initialize core is set up global variables that can be used later in JavaScript, like, for example, set timeout. In order to use set timeout, we need to ensure that this global initialization logic has taken place. So we have to kind of make sure that initialize core is one of the first requires, which is done right now in all of the React Native renderers. And in some cases, what we're actually doing in this global variable, or this global function in this case, is we're just diving right back into native code. We're setting up a native module and calling some native function. And this is the case with set timeout, where we basically call a native module to create a timer in Java or Objective-C. But now, because we have lazy initialization for our native modules, this means this is the place where we're paying the cost to initialize that native timing module. If we use JSI instead, we don't really need to do any of this stuff in JavaScript anymore. Instead, we could just directly create the global variable from C++, and then we can access whatever native code we need to from there. So this has a couple of advantages for us. First of all, we no longer need to ensure that the logic in initialize core is executed before we are able to use this function. So we can do this setup before any JavaScript is executed. And this is really important in cases like exception handling. Right now, we actually do some work to set up error handling in JavaScript in initialize core. This is doing some important stuff like setting up a global error handler, so that when an error gets thrown in JavaScript, it gets properly handled. But what happens if an error gets thrown before this logic can be executed? Well, right now, it basically kind of goes into a black hole, and then something else will probably mysteriously fail later. So that's not great. But by doing this in C++, we can ensure that this error handling logic is executed before any JavaScript is. And then the other reason that why we like this approach is because it means that we can actually remove some native modules from React Native Startup entirely. The only reason that we have the timing module is to call into it from this global setup in JavaScript, so we could just delete that native module. And this is going to be a performance improvement for us because a few lines of C++ are probably going to be faster than initializing the native module, even with the new native modules system. So that's what we're working on in phase 3 of this project, where we're creating a new set of APIs for initializing React Native that explicitly depends on the new renderer and the new native module system and doesn't use the bridge and any of the infrastructure that we no longer need. The main goal of this part of the project is to improve startup performance for React Native. It's also nice because we get to clean up our old code that we don't need anymore, which is always a good thing to do. And this will be faster because we're not initializing the bridge and the other code that we don't need, and also because we're just doing less work in JavaScript and removing some native modules. The new initialization path is still in the very early stages, so I don't have any code to show you. It's not on GitHub yet, but we do have plans to start testing this at Facebook internally by the end of the year. So this probably won't be available until after the first 2 phases of the project later next year. So what does all of this mean for you and your apps or libraries? The new renderer will enable better native interop. All 3 phases together will improve performance, both by removing the overhead of the bridge for native to JavaScript communication, and also by just bringing in some of the performance optimizations that we've been using at Facebook for a while as the default behavior. And also, the behavior is going to get more predictable and just easier to reason about. And this shows up in a few different ways. We have core components like text input and scroll view that, because they now have synchronous measure APIs, will just behave more reliably. We're also introducing type safety between JS and native code in a bunch of different places, which should hopefully reduce bugs. And we're taking the opportunity to rewrite some of the pieces of React Native that don't make a lot of sense, like the way that we currently do error handling in JavaScript. We think that the overall project should bring React Native closer to native frameworks in terms of its performance and in how it behaves. This should make some things easier for you as React Native developers. We think that type safety will help improve the stability of our open source releases because we'll have this contract established between the native code and JavaScript. But more importantly, this will make React Native better for your end users because they'll have more performant, more responsive apps to use. But we're also excited about the longer-term implications of this project. We're thinking about the kinds of capabilities that we want React Native to have in the future, like React Concurrent Mode, and we see this as an important step to get us to where we want to go. So, the new architecture is not here yet. What can we do in the meantime? Well, like I mentioned at the beginning, we don't think that the new architecture should change the way that you use React Native today. And there's a lot you can do with your existing React Native apps to make them better without waiting for the new architecture. First of all, there's a lot you can do to tune the performance of your React Native apps. For example, let's take a look again at how React Native works today. You might notice that that red bar is pretty big. And there's really no reason that the network request can't be taking place in parallel with React Native startup. By fetching your data in parallel, you can get a pretty significant TTI improvement, or at least that's what we've observed with the products at Facebook that use React Native. And another thing you can do, of course, is to enable Hermes in your Android app. Cvetan from the Hermes team is actually here. He's going to be talking about how Hermes works and some of the benefits that you can get by introducing it to your app. This has been a huge win for us, like Mike was saying at the beginning, so I definitely recommend checking that out. And if you're interested in finding out more ways that you can tune the performance of your React Native app, I recommend checking out Ram's talk from Chain React this year. He talked about a whole bunch of ways that you can improve performance in a bunch of different areas. Another thing you can do today is start using either Flow or TypeScript in your app if you're not already doing so. We don't really have an opinion about which one you use, but we think, in our experience, using a type system just makes things so much better. It makes your life easier. And if you need any extra motivation, with the new architecture, we're introducing types type safety guarantees between native code and JavaScript. And so if you don't use any kind of static type checking in JS, then you won't get the full benefit of that. And Jordan from the Flow team is actually here to talk about some of the benefits you can get from using Flow or TypeScript in your apps. Finally, stay tuned for updates. As all of this gets closer, we will be communicating more with you about what to expect, so you can follow us on our blog or Twitter. And we also want to hear from you. One of the reasons we talk about these things before they're actually ready is to get input from all of you and hear your feedback. And in particular, I'm interested in hearing about some of the weird ways you use React Native, maybe in brownfield apps or other platforms, or things that just might affect the work that I'm doing on the new initialization path. We also want to hear your thoughts and concerns, either about this architecture project or just about React Native in general. I'm here with a few people from the React Native core team, so feel free to come and grab us after the talk. That's all I have for today. Thanks so much for listening and for being a part of this community. Enjoy the rest of the conference.